Welcome to the tutorial for Shining 3D Inspect. After importing reference and measured data, you can click Alignments in the top navigation bar to enter the Alignment module, where you can perform Best Fit Alignment, Transform Alignment, Local Alignment, and Matrix Alignment. Through the Best Fit Alignment, you can align the measured model automatically by moving its pose based on the reference model, minimizing the overall average distance deviation. Select the reference data and measured data to be aligned, and edit the parameters sampling rate, maximum iterations, and convergence. Click Apply to see the alignment result in the 3D scene, then click Confirm to save the alignment object, which will be displayed in the align group corresponding to the measured model in the left side tree view. If want to change some parameters when alignment is done, just right-click on the Best Fit Alignment object in the left side tree view to edit the alignment and trigger the recalculation function. Right-click on the Best Fit Alignment object can also export matrix, which can be used for matrix alignment, and we will talk about it later. In cases where the Best Fit Alignment function cannot be used for automatic model alignment, you can use the Transformation Alignment function to manually align the reference and measured models by selecting sets of points on them. Select the measured data to be aligned, and select at least 3 up to 6 sets of points on models in the reference data and measured data window respectively. You can drag the points to change their positions. Right-click on a point to change the tag color of that point, and you can press Delete to delete points. After selecting sets of points, click Apply to see the alignment result in the 3D scene, then click Confirm to save. When Best Fit Alignment result does not meet the actual requirement, you can use the Local Alignment function to fine-tune the alignment by selecting Surface on the reference model, aiming to minimize the average distance deviation of the selected surfaces. Before using the Local Alignment function, it is recommended that you first use the Best Fit or Matrix Alignment function to ensure that the measured model is in a similar pose to the reference model. Otherwise, it may result in the failure of local alignment. Select the measured data to be aligned, edit the parameters sampling rata, max iterations, convergence, and select surfaces on the reference data. Click Apply to see the alignment result, then click Confirm to save. Through the matrix alignment, you can directly move the pose of the measured model and automatically align it based on an existing matrix file, TXT or TRM, or the matrix of an alignment object. Select the measured data to be aligned and select an alignment method, select a file or an align object. Click Apply to see the alignment result, then click Confirm to save. When there are noticeable differences between the pose of the measured model and the reference model, manual alignment can be used to make fine adjustments to the initial position of the measured model. Select the measured data to be aligned, and edit the pan distance or rotation angle of the model on the x/y/z axis. You can also manually drag or rotate the movable coordinate axis at the center of the model. Click Apply to see the alignment result, then click Confirm to save. If workpieces already have a datum system, existing datum can be used for datum alignment. Select the measured data to be aligned, and select the datum features including points, lines, planes, spheres, cylinder axes, and cone axes, one by one. If the datum feature 2 or 3 is selected, readjusting the datum feature 1 will automatically clear the selection of other datums. Click Apply to see the alignment result, then click Confirm to save. By the way, before using the datum alignment function, please ensure that there are at least 3 pairs of datums containing both reference feature and measured feature. And it is recommended that you perform Best Fit Alignment first to automatically align the model preliminarily. For a measured model, multiple alignment methods can be used to calculate multiple alignment results. However, in the current model apply scene, only one alignment result can be displayed. Right-click and activate the alignment object in the left side tree view to determine the current pose of the measured model. Inactive alignment objects can be deleted by right-clicking on them. After aligning reference and measured data, you can use Compare to perform 3D comparison, displaying the deviation between the measured model and the reference model through the color map. Besides, you can also create comparison points on the color map. Select the reference data, the measured data to be aligned in an aligned object, and edit parameters, the upper and lower tolerances and the maximum and minimum values, and choose a ribbon template. The parameters above can also be directly adjusted on the ribbon. The tolerance range should be greater than the difference between the maximum and minimum values, otherwise it will not take effect. Additionally, if the absolute values of the upper tolerance and lower tolerance are the same, adjusting the upper tolerance will cause the lower tolerance to change synchronously. If the absolute values of the maximum and minimum values are the same, adjusting the maximum value will cause the minimum value to change synchronously. Click Apply to display the 3D color map in the scene and the ribbon in the right. And in the preview state, you can click on the 3D color map in the scene to create comparison points, or right-click on one 3D compare object in the tree view, click Edit Comparison Points, and click on the 3D color map to create. For the created comparison points, you can use mouse left to drag or click Delete to delete. Then click Confirm to save the 3D compare object, which will be displayed in the Compare module in the left side tree view. As the 3D compare object is associated with the align object, the 3D compare object can only be checked when the associated align object is activated. Multiple 3D compare objects can be created for one align object, and each 3D compare object has one individual ribbon. On the right side ribbon, you can enter values by left-click on the input box or use stepper, so as to adjust the tolerance range and the maximum and minimum values. You can also drag up and down to adjust the tolerance range. When adjusting values, the parameter value in the 3D compare window and the 3D color map in the scene will be updated in real time. That's all for this tutorial. For the next video I will show you how to create features. Thanks for watching.